Hello, my name is RohanChouthai. I'm an engineering management graduate student at Northeastern University, and I've done the project on Boston Airbnb analysis for my introduction to data mining and machine learning course. Now, Boston, we all know, is a major educational, business and tourist hub on the east coast of United States, which attracts lots of tourists every year. Airbnb has become an integral part of the travel community and indeed a great source of income for the people who are fortunate enough to own homes in cities like Boston, which they can rent out to the tourists. Now, they'd surely be wondering though, how much money is their place likely to be worth on Airbnb? Similarly, the people who do own a house on Airbnb would want to improve the quality of their listing. Also, from a tourist perspective, if I want to live in Boston for a couple of nights, I'd like to know what neighborhoods are better to find myself an accommodation in. So all this and more is what my project would aim to shed some light on. Now, I'd start off by explaining where my dataset comes from. So this dataset is from Kaggle. This dataset originally is actually a part of the datasets which Airbnb has compiled for the housing for the Airbnb listings throughout different cities throughout the world. So this particular one is the dataset on the Airbnb listings in Boston. Now, this dataset actually consists of three individual datasets, namely the calendar, listings, and the reviews. Now, the calendar dataset is actually a dataset which has the historical record of the availability of the listings. It's a large dataset, and it's not something I have used at all for my project. I'm sorry. Then is the listing dataset. Now, the listing dataset basically has the listings of the Airbnb of the apartments or the houses which are listed out on Airbnb. This dataset has a lot of information about the listing in particular, which includes the number of bedrooms, number of bathrooms, the average nightly price, and so on and so forth. So this is the dataset which I have used to create both my classification and my prediction models on. This dataset consists of around 3,500 rows and some 69 columns, which are all attributes of the apartments which are listed out on Airbnb. And lastly, the third dataset consists of the reviews of all these listings. Now, it has a unique identifier named listing ID, for which all the reviews have been given. So, in short, this dataset comprises of all the Airbnb listings for which the reviews have been recorded. I also have done a sentiment analysis on the Airbnb reviews with the aim of finding out which are the neighborhoods which particularly have a good sentiment score for. I'll obviously get into more details when we get to that part of the project. So we saw the dataset description, and it suffices to say that the project actually follows all the steps of RISC-DM which are applicable in this case. Now, after having understood what the data actually looks like, I just go on to show how I've imported the data into R by using the simple read.csv command line. By just importing the data into R, I have then proceeded on to analyze the data. Now, to go into the specifics of all the three datasets, we can see that the calendar dataset consists of about 1.3 million rows and 4 columns. The listings dataset, which I've used extensively, consists of about 3.5 thousand rows and 95 columns, and the reviews dataset consists of about 68,000 rows and 6 columns. So as I said, I'd be mostly using the listings and the reviews datasets for my purposes, and the reviews dataset will obviously be used for the sentiment analysis during the latter part of the project. Now I'll just start off by explaining some of the exploratory data analysis which I did. Now you know that in a city as expensive as Boston, there's obviously a lot of curiosity as to which areas actually are the most expensive around the city. The listings dataset actually has a lot of information about the neighborhood and the prices of the listings therein. So I'll now explore which areas are the most expensive in Boston. So now you can see by just running a simple command where I just pulled up all the important parameters which I thought would be useful in helping us visualize the most expensive areas. I've made this data frame called daily price, and then I have just gone on to do some more analysis where the data needs to be a bit ready. So the price variable, it's not in the right format. It's in the form of factor. So I've just converted into an integer, and then I have indeed went on to make another data frame where I have summarized the average price for the neighborhood, as we can see over here. And now we can actually see that the Hyde Park neighborhood is the most expensive, followed by Mattapan and Longwood Medical Area. We do get an idea of which neighborhoods are most expensive, but obviously it always helps us to sort of get an even better idea when we actually visualize it in the form of a bar plot. So I've just gone on and plotted this data frame using ggplot. And here we can see that Hyde Park, as we saw, has the most expensive places around Boston as far as the Airbnbs go, followed by Mattapan, Longwood Medical Area, and North End seems to have the least average price for a night of Airbnb rental. Now having done that, we'll move on to building the models. But before building the models, we obviously need to make sure that our data is in the right format. We need to prepare the data. Now for doing that, I needed to firstly check if there are a lot of NA values in my dataset, and sure enough, the listings dataset consists of a lot of information which has URLs, host images, and stuff like that. So it didn't make sense for me to do an entire NA value check on the entire data set, and so I have done the NA value check and imputed the values as and when the time came, when I actually built the model by subsetting the data frame with the important values which I'd be using for my analysis. So we saw how I'd be imputing the values, the NA values, later on when I build the model. Now I'd walk you through the models which I've built. I've specifically built 4 different models. 2 of them are classification models and 2 of them are prediction models. In the prediction models, I wish to predict the price of housing per night in Boston, and for that I've used the linear regression model. First, of course, I visualized the distribution of my dependent variable, which is the price, and it looked like it doesn't really have too much of a skewed distribution. So I decided to proceed with the variable as is for the time being. Then, of course, comes the data imputation part, where I had to first see whether there are any NA values, and when I ran an sapply command on my data frame, it looked like there are a lot of NA values in my bedrooms, bathrooms, and beds. Now of course I wanted to impute these values, and so I decided to impute them with the value of means. With the value of boards, because the value of means doesn't really make much sense when I'm imputing the values of bathrooms and bedrooms and beds. So I developed a function called mode value, as we can see here, which sort of helped me find the mode of a column, and then went on to impute the missing values or the NA values with mode. and then after having imputed that, I just confirm whether the data frame doesn't have any values, and it doesn't have any values as it turns out. And that's how I proceeded on to sort of visualizing the correlation between my coefficients. And as we can see in this graph here, there's a lot of collinearity between my independent variables. Now the aim here is to sort of build a model which can extract a lot of information from a relatively lower dimensional correlation between its independent variables. And actually the idea is to eliminate all the collinearity, and for that purpose I've used the principal component analysis to build the model. Of course, before proceeding to the principal component analysis, I had to normalize the data which I did, and then sort of went on to do the PCA. And from this plot here, what I observed was that 10 principal components in my data explained about 95% of the variance, and so that is good enough for us to proceed to build the model. Hence I decided to move forward with those 10 principal components and built my model, linear regression model, based on those 10 principal components. And then I needed to sort of check how my model performed, so I developed an RMSE function, as we can see over here, which will help me calculate the root mean square error between my prediction and the test data set which I had made from my original data frame. And it turned out that the RMSE was 1.15, which is good enough. Now, of course, this is a small data set of around 3,500 rows, and hence it made sense for me to sort of check what would happen if I actually did cross-validation instead of dividing it into training and testing data sets. Because obviously, as we know that for cross-validation, we specifically use cross-validation for smaller data frames, because if we use the small data frame both for training and testing, there's a risk of the model being overfit. So I developed a function to sort of cross-validate the linear regression model, and it would return out the root mean squared error, because that is what I am checking with regards to my model, right? So I found out that RMS is actually quite large after I did cross validation. The next model obviously I built was random forest model, again with using the by using the PCA data frames which I had developed for the previous linear regression model, and I found out that the random forest model was much better with a RMSE of 1.15, and after cross validation the RMSE was 0.24. I concluded that the random forest model with cross validation was the best fit for predicting the prices of the Airbnb listings per night. That is the yield prediction problem which I talked about at the beginning of the presentation. I'll move over to the classification models now. For my classification models, I wanted to predict whether a host will be classified as a superhost or a normal host. So I built two models, a neural network model and a random forest model. So the classification models, for the neural network model, I got an accuracy of 89% with and for the random forest model, I got an accuracy of I got an accuracy of 91%. I also wanted to build a model ensemble so as to sort of develop a more robust model than any of these individual models, and so I went on to build the model ensemble as we can see over here, and sort of ran the model on the data set which I had made. This data set actually comprised of the predictions of the earlier two models and a third column which consisted of the decision variable. After running the confusion matrix, I observed that the accuracy of the model ensemble was the greatest, that is 92.32%. Thus, in summary, we built four models. Two of them were predictor models, two of them were classification models, and I employed various different techniques like cross validation. I used PCA to actually select the features for modeling my predictor models. I found that random forest had the most accuracy for my for my predictor models when it was used with cross validation, while the model ensemble of random forest and neural network had the most accuracy for my classification models. I will now move over to the part B of my project, that is the sentiment analysis. Let us now move over to the sentiment analysis part of the project. We saw the most expensive neighborhoods in the exploratory data analysis, but I also wanted to explore as to what sentiments are associated with each of these neighborhoods. So for that purpose, what I did was I used the reviews data set from the entire pack of data sets, and now what I did was I used the tidyr and tidy text format to do the sentiment analysis, where I first unnested the tokens, where I divided the comments into words per listing, and then I went on to sort of do an anti-join to remove the stop words. Now for this data frame, then I used the Bing sentiment to assign a positive or a negative sentiment score to each of the words in each of the comment, and the idea is to now group these sentiments by the neighborhood. Now obviously I didn't have that sort of data in the reviews data frame, so what I did was I used a join to I used a join, as we can see here, a left join on my listings data set to bring those columns into this data set, and now I sort of summarized the sentiment for each of the neighborhoods, and sort of also added the price dimension to it. After running the data frame, as we can see here, I have this data frame which shows that Alston, for example, has an overall sentiment score of 54, while average price of $200 per night. Now the idea here is to sort of plot and analyze what sort of sentiment is attached to each neighborhood and how expensive it is to actually stay in that neighborhood. So we go on and run this map, run this ggplot to have this plot, where we can see that the Longwood medical area is one of the more expensive places with a large sentiment score as well. That's people like to live in Longwood medical area, whereas the Hyde Park area doesn't really have that bigger sentiment score despite being more expensive. We also find a few cheaper places to live in Boston with a relatively decentish sentiment score. Thus we can see that we have deployed both the classification and prediction models in this project, as well as done a sentiment analysis of the reviews of the Airbnb dataset. I will thus conclude the project, and as a part of the deployment phase of the project, I have published the HTML file on RPubs. Thank you.